Hey guys, welcome back to another video, and today we'll be discussing about an interesting topic from artificial intelligence, which is genetic algorithm. Sadly, genetic algorithm isn't about genes, bummer I know, but the story behind it is quite fun. So, there lived a king who had 4 queens, and with no surprise, none of them liked one another. The situation was so bad they didn't want to stay in rooms that were in the same row, same column, or even same diagonal room. So if we had queen 1 here, so none of these other queens would stay in these rooms. And again, so we have to look into the other rooms that are available for us and put in the second queen there, and so on. The process goes on. Now the king called a professor, Mr. John Holland, to help him out with the problem, and the professor solved the problem using backtracking, meaning he started out with 1 queen, looked into the places the next queen can go, and the process went on and on until there is 0 clashes. So the first queen is here, so the other queens cannot go into these places that I marked. So the options only you have this one and this one and this one and this one. So between all these places you have to put the other queens and then look into your other options, and this process is quite tedious. And looking into each place, getting stuck, then looking into alternative places, and the number of queen, and as the number of queen increases, the problem becomes much harder to solve. And this is what happened. So the king married another queen, so now it becomes the 5 queen problem. Previously it was the 4 queen problem, and again the king had now 6 queens, so the problem became very hard to solve using backtracking. And I guess you can understand that if the king had like 10-12 queens, it would be very hard for Mr. Holland to solve that using backtracking. So finally, the professor decided to make an algorithm, which is our topic of discussion today. There are a few things that we need to understand before going into genetic algorithm. The first one being the fitness function. So the fitness function is basically the number of non-attacking pairs of queens. So first of all, we need to find the maximum number of pairs. So the equation is basically n into n minus 1 divided by 2, n being the number of queens that we have. So in this case we have 8 queens, so for both of these cases we have 8 queens, so we put 8 here, n minus 1, that would be 7 divided by 2. So this is the maximum number of pairs that we can have for this situation, and the fitness function would be basically the maximum number of pairs minus the attacking pairs. So if we look into this example here, we have to find the attacking pairs. So the first attacking pair is this one. So remember, all the rows, all the diagonal rooms, and all the columns. So let's try to find out. So this one was 1, this is 2, this is 3, and where is 4? And another one which is 4. So we have 4 attacking pairs. Now to find the fitness, we do 28, which is our maximum number of pairs, minus the attacking pairs, which is 4, which thus we get 24. This is the fitness function of this corresponding situation. Now the fitness function, the maximum value could be 28, where we don't have any attacking pairs, and which is the end goal, and the lowest could be 0, where we have 28 pairs and 28 of them clashes with one another. Now moving on, so there is a chromosome. For this case, this is the chromosome of the father and this is the chromosome of the mother. So even though genetic algorithm is not related to genetics, but it follows the same concepts. Here the chromosomes represent the position of each queen. So if you look into the first one, the chromosome of the father, so 3 is the position of one queen, 8 is the position of the second, 4 is the position of the for third queen, and this is how you like write the chromosome sequence. And in the exam you might be given this, or you might be told to make your own chromosome sequence. Now this is the whole pseudocode of GA, or genetic algorithm, and the first step is to generate the initial population. So the population is basically the chromosome sequence that I talked about, and compute the fitness. So n into n minus 1 by 2, then you minus the fitness functions, then you minus the attacking pairs, and thus you get the fitness function, and then you do this whole process. So we do selection, crossover, mutation, and compute the fitness again and again until the whole process gives us the maximum fitness. So first on is crossover. So after doing all the work, we find a crossover point. The point could be, so the point, this point is basically could be anywhere. It doesn't have any specific places unless the question says so. After finding the point, we swap the values on the left side of the point with the other chromosome. So this is our crossover point, and we swap the values on the left side. So that's what we are doing. So 7 goes here, and so basically we're exchanging the values. So 2 goes at the bottom, 1 goes at the top, 6 goes at the top, 3 goes at the bottom, and this is the final result. So this is the offspring. When you have a child, basically the child is has a chromosome that is mixed with both the fathers and the mothers, so that's why it's called the offspring. And this is the result that you get for the crossover. After the crossover, we go to mutation. So mutation is basically really easy. You just pick one point here in the chromosome sequence and you increase it by 1. So basically we are taking 1 here and increase it by 1, so this becomes 2. Take 5, increase it by 1 to get 6. Now this is another offspring, and in this offspring, if you find the fitness function for this, you can see the fitness function for the chromosome of the father or the offspring 1 gives us 0 attacking pairs, which is our goal, right? We have to have the highest fitness possible, and that's what we get. On the other hand, in offspring 2, we still have 5 attacking pairs, so we need to work on this a bit more. So that is how you solve the genetic algorithm problem, and it's quite easy. And in the exam you would be asked to do mutation and crossovers and then find the fitness function, and this is an iterative process, so you would be given like up to 2-3 iterations, and this is where genetic algorithm is basically used. And hope you guys did understand the concepts of genetic algorithm, and if you were wondering about if it's related to genes or not, I'm sorry to disappoint, but it's a very interesting topic and a very easy one. So hope you guys did understand it, and thank you for watching.